Am I audible to you, friend?
Yes,
Hello.
sir.
Yeah, yeah. Good evening, all of you.
Good evening, sir.
Yeah. We already talking about the pipe plant, right? There are many variation uh, in the pipe plant. There are different type of pipes. You know that 100 pipe, 15 pipe. But there is a one definition of a pipe, that is the internal diameter should be 12 mm. Above that, we can say it is a pipe. But when the internal diameter is below 12 mm, it is called as a tubing. Therefore, this is a major difference between tubing and a pipe. Inside diameter, internal diameter, it should be at 12 mm. Above that, it is called as a pipe, and below that, it is called as a tubing or a hose pipe. Now, friend, we have seen a number of videos, right, about the pipe. Uh, see, the pipe should be uh, the material which we are using for the pipe is polyvinyl chloride. I told you this is a largest consumption in the market. Second number is the polyolefins. Polyolefin means polypropylene and polyethylene. We are manufacturing a pipe that is without chlorine, polypropylene and polyethylene. But major consumption is, I told you, is a PVC. Both PVC flexible as well as PVC rigid PVC. It is also called as a RPVC and FPVC, or UPVC and FPVC. Friend, the wall thickness and flexibility and rigidity differentiate between the tube and pipe. That I told you already, there is the one definition. They always keep in mind, that is a 12 mm, the limit for the pipe. Generally, the pipes are produced horizontally. That means it is extruded in a molten form horizontally through the annular gap of the die, mandrel, and the die body. Then after that, there is a screen pack, radical plate, and sizing units are there. And after that, cooling tank and the further inline equipments are there to stabilize the final dimension of the pipe. See now, this is a basic diagram of the pipe plant. First is the extruder. Now, what are the necessary conditions for the extruder? I have shown you that screw for the PVC, screw for the nylon, screw for the a general purpose is a SDP paper polypropylene material. And here, ABS material also used to manufacture the pipes. Remember this thing. Not only polypropylene and PVC, ABS also we can use to manufacture the pipe. Now, this extruder should be suitable to extrude the given material. Material may be vinyl polymer or maybe olefin polymer. The screw should be able to process the material. There are a different design of the screws throughout the compression zone for PVC, very short compression zone for nylon, a 50% fit zone for polyethylene, and 25% for metering and compression section. Just the basic general idea about the design of the screws. Now that already we have seen. Now regarding the dies, I told you that day there are three type of dies: straight through die, cross-set die, and offset die. We are using these dies as per our applications. Straight through die, I told you the material get flow in a straight line, making the angle 180. Extruder and the inline equipments. So friends, you could see inline equipment straight through dies are there where the material flow in a 180 angle. I also told you a compression die, cross-set die. These dies are used for generally for blown film. And offset die, it is also, I told you that material travel through 290 angles. And hence, these materials, this die, offset die is used for a stable material, where that material flow in a from barrel, screw, rim packs, better plate, and 190 angle and the second 90 angle. Frame, these dies are play very important role because that give the final shape to your a pipe. If you want a shining inside a pipe, yes, you will definitely get. Therefore, there is a mandrel. We have seen the design of the die also. A die body is there, convergence section is there, divergence section is there. The centering screws are there to adjust the thickness of the pipe. Now, we can create the hollow pipe by passing the ear. We have already drilled a bore, a hole in the die body through the leg of the spider, and it goes the straight with 90 angle with the mandrel. And we can try to keep the compressor ear inside the pipe so that pipe should not collapse at the exit of the die. These are the main criteria for the die. We have already seen these dies. See now here, this is the pipe die I told you. The material, here is a breaker plate and screen packs. The material enter from this side. It will get sprayed here. This is a die body friend. This is a convergence section and this is a divergence section. See. So any die divided into two parts. One is convergence section, other is a divergence section. I told you this is a mandrel here frame. The mandrel will try to help the straight line structure of the chains of the polymer. See here, the hole is drilled here to pass the compressor here. See here, the pipe is coming out from this and this exists round pipe, and there is chances to collapse this pipe here. To avoid that, we are given a air passage. See here, 90 angle we have drilled here. Through the, this is a mandrel. This B is a mandrel. A is a die body. It's a die body. C is a die bushing. It's a die bushing here, friends. K is a die land. It's very important. The H is ear hole. where we are passing the compress here. And this is spider. This is spider. This is a place here, here, here. This is a place here. And through this spider, we are drilling the hole like this here. And after that, see now, this is spider here. We drill hole here and then it have a passage in the mandrel. Now, if you see, this F is a die centering. We can adjust this bush with the help of this uh, bolt. This is F bolt is given here. Therefore, suppose thickness is higher in this case. Just we give some rotation to that, the bush will get shifted this side and this distance will be decreased. And therefore, thickness will be reduced. Therefore, there are four centering screws around the die. It's a round one. It's a round one. Here we are just looking at the cross section of this pipe die. Now we have seen the die centering bolt here, friend. Now there is also another bolt. It is called as a die retaining bolt. Here, die retaining bolt, which will hold this die body and this bush. After that, the die retaining ring is there. See here, this is a die retaining ring. Die retaining ring is get, that hold with the die body with the help of this E bolt. That is called the die retaining bolt. We have seen the die bushing here. It is a B is a mandrel here. If you see now here, spider leg, I told you this spider leg here, friend. Through this, we are drilling the hole. See this spider. There are 1, 2, and 3 spider legs, and this portion is what? A vacant completely. From this, the material. This is the passage to pass the material, molten mass. When the material enter through this from the barrel to the breaker plate, screen packs, and the die. I told you it's a conversion section where the material get converted as per the proper shape in the divergence section. Now, friend, this is called as a straight through die. See now, here is a barrel. I told you barrel is this side, and hence it is showing a 180 angle here, straight. But see now, this is a cross-head die. The material barrel is here, this side. This is a breaker plate, the die body. And see here, this is a mandrel, another mandrel here. But this die is not used for the pipe purpose. This die is used for the another purpose. That is called as a wire and cable. This is a wire and cable die. This is a pipe die, friend. The material coming through this die body. The barrel is here, breaker plate is there, half part of the breaker plate is with the barrel, and the material gets sprayed here, over here, and here, this is the passage, hole is there. This hole is provided to pass the copper wire. Copper wire. Therefore, copper wire passed from this hole, and the material coming through this and this passage. Completely annular gap. The all side, or circular side here, like this. See, this again die bush are there. Die ring is there. Retaining bolts are there. Centering bolts are there. so that how much coat, how much insulation we have to apply on the cable or the wire. We can easily adjust with the help of F bolt. That is centering bolt. This is centering bolt. So friend, this is a brief idea about a pipe die and a wire and cable die. Therefore, wire and cable die, we are using which die? Crosshead die. For pipe, we are using straight through die. Remember this thing. These are the very important. We should not use a crosshead die for pipe. Now, friend, if you see here, a die is here. Here is the extruder. The arrow indicates the extruder here. Here is the breaker plate and screen packs are here. See, the die and the sizing sleeve, sizing unit. Now, sizing unit, which will give the accurate shape to the pipe. There are 4 types of sizing units. I told you that day only. Vacuum trap, sizing sleeve, extended mandrel, and the sizing plates. These are the 4 main types of the sizing units you will observe in the plant. Now, I told you 12 mm and above inside diameter, that is called as a pipe. There may be 100 mm pipe. There may be 1000 mm pipe available in the market. There are also a collapsible pipe. Once the work over, we can fold it and we can keep in our house, store it properly. That is called as a collapsible pipe. There are some pipe we are using for the outlet of your washing machine. Even your outlet of the basin, hand wash basin. Even the outlet of the kitchen, utensil washing pot to the outlet. So friend, we are using this a corrugated pipe for that purpose. Now, how these pipes are manufactured? You have seen the agriculture pipe, maybe 22 or 20 feet length, diameter maybe 100 mm, more than that. There are different varieties of the agriculture pipes. So friend, here sizing device is very important. We will go in detail now. Trap sizing, I told you, sleeve sizing, mandrel, extended mandrel sizing, and the sizing plates. When you are going to use these sizings methods, devices, now the cooling bar. This is a cooling bar. After sizing, there is a gap. How much gap is there, friend? Hello? Am I audible to you?
Yes, sir.
Yes. Friend,
Around 100 to 200 mm, 100 mm gap we are keeping.
yeah, 100 mm. Generally, we are depends upon the pipe size, nature of the material, this gap, sizing sleeve, and this die gap, we are always putting here 2 to 12, 2 to 8 inch. 2 to 8 inch generally. Therefore, friend, this sizing sleeve we will go in detail. After that, after sizing sleeve, when the pipe comes through the sizing sleeve or sizing unit, it passes into a cooling tank. Now, cooling tank depends upon the size of the pipe. If you have a 1000 millimeter diameter pipe, then it required a very big cooling drum, cooling tank. You can say it's a cooling tank. Outlet and inlet. Here is the inlet, outlet. See, the many times the flow, water flow like this. It is not like this. If you start the cooling here only, what will happen? The pipe will try to shrink here maximum. Therefore, the water may be from this side or maybe from this side, and it will go like this. And then it got a moment like this. Even we are spraying water from this side, from top side. So cooling tank, the length of the cooling tank depends upon the material, their structure of the material. I told you, there are two types of plastics: crystalline plastics, amorphous plastic, and semi-crystalline plastics. I told you also the amorphous material, amorphous plastic, they cool very fast and they heat very fast. But in case of crystalline plastics, they take a more time to heat and they take the more time to cool. And hence, this cooling tank size and length depends on that. How the cooling tank size affect? Can anybody judge, Fred, for amorphous material and for crystalline material, the length of the tank? Hello? Can anybody tell me the length of the pipe tank?
Length of the tank, sir?
Cooling tank.
It's around 6 meter.
Yes, 6 meter.
Huh.
It is a 6 meter for some material, but it is also higher for some material.
Yes, sir. If you go for a higher size, sir, then we will maintain up to 12, sometimes 3 tank 18 meter.
Correct. You are right.
Depend upon size.
Yes, because you are 100% right. For amorphous material, now amorphous, for example, PVC. For PVC, we don't want very long length pipe, cooling tank. We want 6 to 7 meter. Okay. Because PVC cool very fast. But if the material is polyolefin, polypropylene or polyethylene, then you have to increase double, maybe 12 meter. How much? 12 meter. Why this? Can anybody tell me why 12 meter? Why 12 meter size required here for polyethylene, polypropylene? And why PVC only 6 meter is sufficient? Why polyethylene, polypropylene require a 12 meter? Can you tell me?
Sir, we are doing compounding of engineering material like nylon and some PP, ABS also. But
correct.
we are using the same cooling tank six meter length only for all the material.
No, that is a
But
no.
in
That
that,
is
dep
yes, yes. Please talk.
but in that, depending upon the material, we are uh, keeping it. Some material are kept for a longer distance in the water in the cooling tank, and some material like nylon and all that are kept only for 1 or 2 meter only for in the cooling tank.
Correct, correct. Why this?
Means some material we need to means we need to cool it faster. Means like if nylon material is there, we should not make it. We should not cool it because while doing the cutting at the pelletizer, it will not cut. And
Correct.
some soft material like PP and all, we can cool it and we can cut in the pelletizer for that reason.
Correct, correct. You are 100% correct. But see now, in a pipe production, in a pipe, if you see the pipe production, there you are making the granules of that. Therefore, again granules you are going to again reprocess for pipe or maybe any type of product. But friend, if you see for a final product, you require a specific size, length of this cooling tank. There's no effect on the granules because granules they have to cool. They we have to cut very immediate. For example, nylon, and that's why we are keeping a very hot condition. It will should be cut immediately. But if you see here in this case, a pipe, polyethylene pipe, or maybe a polypropylene pipe, it is crystalline material, semi-crystalline material, and therefore we are keeping a longer because it cool slowly, and that's why we have to keep this a longer. To remove the completely heat from the product. If you keep the 6 meter length of the cooling tank for polypropylene or SDP, what will happen? The pipe is not completely cool, 100% in a cooling tank. The 50% it will cool here and 50% outside. And therefore, there is chances to get warpage or many things will be there. Some fault will be there in the pipe. Because you are not given sufficient cooling time here, friend. Your pipe may be break immediately. And hence, you require a higher length for PP and SDP as compared to PVC. PVC, I told you, cool very fast, heat very fast. But polypropylene or polyethylene, it takes more time to cool and more time to heat. You have seen while designing the screw also. Now, if in case of the cooling tank of the wire and wire, insulation wire, there, suppose a cooling tank is very, compact. We are giving it, here 2-3 pass. Here wire jayega, वापस it will turn like this, वापस turn like this, वापस turn like this, like this. There may be 3 to 4 passes because it takes more time to cool. Now, after a cooling tank, friend, there is a hollow unit. There is a belt are there, maybe from a polyurethane material, two belt, two endless belt. They rotate counterwise like this. And there is a continuous pulling force on the pipe. And after
Sir, I have
that,
one doubt.
yeah, yeah.
In our extrusion process, all the machines having cooling tank, now they are using only water for cooling or any other liquids, something
No,
chemicals.
no, only water,
Mhm.
only water.
Is there
Correct.
any reason, sir?
So water is a solvent actually, and
Okay.
it can extract the heat easily than the other material, and hence we are keeping water is the best, for cooling purpose, like fluid.
Okay, sir.
Now here is a continuous pull on the pipe that is called as a caterpillar or maybe hollow up unit. So caterpillar भी बोलते हैं, hollow up unit भी बोलते हैं. Now finally, again there are 3 to 4 equipment also there. The size of pipe, diameter of pipe. Therefore, there may be beta gauge here, beta gauge, which will give the final thickness of the diameter of the pipe. After beta gauge, there may be a corona treatment given to the pipe. After corona treatment, there may be labeling, or maybe foot counter. How much foot you have manufactured in one ship. Therefore, there may be footer. Footer is there, which will measure the length of the pipe production. After that, there may be corona treatment. Corona treatments given to the some specific material. After that is a printing unit, which will print the ISI trademark, material, manufacturing date, name of company, everything company will print on the pipe. And the finally is a cutter or maybe winding unit. Pipe, if the flexible pipe is there, into wind on the winder. Here, a cut-off unit or cut-off saw is there. There may be a wheel rotate continuously and it will traveling. This cutter will travel with the pipe. Suppose you want a 20 feet here pipe. The cutter has some inclined position. It will go with this pipe. When it is become a 20 feet, immediately it will cut. But the cutting start from the very initial stage at the starting point only. After cutting, again this cutter will open and it will slide like this. Again coming back here. Very simple cutter. And you can easily cut that pipe with the help of the wheel, which have some thread on that for the cutting purpose. Any question here? Any question here? Hello.
Oh, from my side, sir.
Ha. Friend, I will show you. We have seen this also. I will just show you one video. You maybe have seen that video. It is a caterpillar here, caterpillar. It will pull the pipe continuously. And see here, spiral bending is there, machine. Which will do the completely threading inside here. Again, it will hit the chamber. Again, see from this place and this place, the material get coated on this again. See now here. See die is here for this. And the second die is this side. See the hose pipe friend. See the die is here from this and here, second die. There are three extruder, therefore three control panels are there. The cooling tank, see here, caterpillar, which will pull the pipe. See rubber, endless caterpillar is there. And finally, you are getting the hose pipe here. He's adding color master badge there, friend. Here, the PVC is get completely powder, completely mixing here. Dry blend mixing. See, the hopper loader is there. The material get, poured in the hopper loader. With the hopper loader in the hopper, is a die sizing sleeve. Is the pipe. Here's a diameter calibration. See here, the weight is there. Cutter is there. See, this is a cutter which will cut the pipe. See, automatic baling is there, friend. You see, automatic bedding here. See, the pipe size increase here to join pipe one to another, right? Therefore, from both side of pipe, they are doing some uh, automatic belling machine is there. See now, you can see this, how the diameter of pipe goes on increasing and the end of the pipe. We can use these for the connection purpose, connection, join. See now here, diameter increases. Again, see this. See, automatic belling machine. See how that comes. After that labeling, then recycling waste. Last, fourth step. Suppose pipe is not good initial material, you have to cut and you have to add that pipe in a crusher. Again, this granule will 20% or 10% you can add with the virgin material. See now here, they added the scrap here. This now mixing the scrap here. Collecting the scrap also. See again fine powder. They have a different type of units friend. You have seen the hose pipe also. You have seen uh, the threaded pipe. See, this is a unique pipe manufacturing at a very remote place. There are they are manufacturing the pipe from the scrap PVC. See how they are manufacturing. This is a unique video. You can see now here. See here, friend, how the scrap converted into the, the granules. If you see here, there's a dry paste cutter. See here, there's a dye paste cutter here. See here, friend, the dye paste cutter is there. See now here. Okay, this a motor is there. See now how the granules are get cut here. See how the granules are get cut. The knife is rotating around the face of the die. See that the cutter blade is get rotated on the face of the die, and therefore you are getting a pellets without that cooling also. And after that pellet they are using to manufacture the pipe. See now here, friend, they are manufacturing the pipe rigid PVC pipe. See how the cooling is provided. See the printing unit, which will print the manufacturing date. Is a pulling unit, which will continuous keep the pulling effect on the pipe. The cutter is there. See now here, when this pipe will touch the front side immediately, see now, it is coming forward. When you touch here, one flap, immediately it will cut. See now here. When it touch, see now, immediately it will cut here. See now, the cutter will get, it is a mechanical arrangement, not limit switch, friend. See now, this give a signal to here, to the cutter, to this cutter. See the arrangement, mechanical arrangement. Or these are the PVC pipe, rigid PVC pipe. Friend, we have seen 2 to 3 video of how the pipe is manufactured, how it is manufactured from the scrap also, how the scrap is used to make the granules by using a die paste cutter. Okay, we have also seen the pipe or hose pipe which is used in the garden, how it is get wrapped with the threads. See, these are the unique videos you can see, and you can learn many things about the pipe manufacturing process. Now, we have seen also these dies used to manufacture the pipe, straight through die and cross-set die. Now, reprocess plant with die paste cutter. That already we have seen, but how this again we'll get additional knowledge of a die paste cutter, because nowadays the time is also very less. The space for the machines are very less. Within a 10 by 10 area, we have to accommodate the machine, and we can start the plant. That is a reprocess of a material or recycling of the material. So friend, this die paste cutter is accepted by industry for some material, maybe PVC. There are two types of paste cutter, dry paste cutter and wet paste cutter. We have seen in the first video, there is a dry paste cutter. Dry means there is no water at all. The knife is rotating on the face of the die. That again I have shown you there. 2 times I have stopped the video and I have shown you that a dry die paste cutter. Now we are going to see wet dry paste cutter. Wet dry paste cutter means what? That pellets are get gathered in the water. The pellets are get cut on the die paste only. Die paste only. But with the help of water, water is also there, one medium. And the granules flow with the water, and then after some time the water gets separated and the granule gets separated. Again it get sucked into the oven. They dry there. And again we can use for the recycling purpose. Now I am showing you this video, friend. This is called as a wet die paste cutter. Wet die paste cutter. If you have any difficulty or any question of any video, please tell me. I will again show you and again explain to you. See this video, how the granules are get cut at the die face, and how that carry. See, these are the blowers. These are the blowers to cool the barrel. Here is the extruder. This is a barrel. See, I had shown you this is a breaker plate. See, the motor is there. See here, a die paste cutter is there. Wet paste cutter. See now here the granule fall in the water. And see now, you are getting here the pellets or granules. You are getting higher production, less area. There's not require a cooling trap. It is just granule get cut at the die face, and that are get collected in the bin. See now here, you are getting a lot of granules here, friend. Very fast production. See now here. See, motor is here from this side and get cut here, all granules, and they get gathered here with the water. The granule get separated after by the drying, and then get back in the bin. Now, friend, we will take 2 minute break here, friend. Hello. Hello.
Okay, sir.
Yeah, we will take 2 minutes. Then I will show you say this video. After that, we will go through the sizing techniques and our corrugated pipe manufacturing process. See, friend, here is also how it is a get manufactured. Very simple process. There is a dry phase cutter. Again, here see how the water is, the granule get cut here on the dry phase cutter. See the water and the granules. They are falling here, and see the continuous, they are flowing with the water. Okay. See now here how there after that water will go out and the granule gets separated here, friend. This is called as a wet dry phase cutter. Wet dry phase cutter. See the path goes on narrow now. The granule go ahead and the water fall down. See, water is gathered here, water. This is a very simple process nowadays because in old days, we have a very cooling trap, long cooling trap, and we require a lot of space for that. But now see, this is a very immediate process, and the production is also very fast. The material which has not hydrophilic in nature, they can be used on this machine. That is a wet dye phase cutter. Remember this thing. And I told you the dry dye phase cutter is used for non-hygroscopic material. Okay. That have a hydrophobic nature. That material having a hydrophobic nature. And for hydrophilic nature, we have another machine that is called as a dry dye phase cutter, right? Therefore, there are two type of cutters are available for granules. Now, these granules we can store in a bin with the help of hopper dryer. This hopper dryer will dry completely these granules because here the material is not hydrophilic in nature. The material is hydrophobic in nature, and that's why we are using this type of things here, friend. Here the granule having only the surface water. See, this is they are showing here a breaker plate. Okay. And see the granules are gathered here this side. These are just get dry by the oven. And see now here they are gathered in this a rectangle bin. These all are, I told you, hydrophobic in nature. Hydrophobic means they don't have an affinity with the water. Hydrophobic and hydrophilic. Remember this thing. For hydrophobic, we are using the wet dye phase cutter, and for hydrophilic, we are using dry dye phase cutter. Remember this thing, two things. Now, sizing equipment, friend. I told you while manufacturing the pipe, there are 4 techniques. One is vacuum trap techniques that we have seen in many videos. Vacuum trap, exposure to the atmospheric pressure. It is a widely used friend in the market. With the help of vacuum, pipe is stabilized and sized to retain the shape. See now here, the vacuum is applied here, friend. The pipe is going like this from this place. Okay. See, the vacuum is again applied here. Vacuum is applied here. Therefore, there's a continuous atmospheric pressure, at the outside of this. But here, due to vacuum, the pipe is not collapse here, friend. And you will get a shining. See, if you want a good shine on the pipe, then you have to use a vacuum trap method. Remember this thing. Outside the diameter, outside the pipe, if you want to good finish, then use this. Secondly, this here is a sleeve is a perforated. This is a perforated one, and therefore the pipe gets small lubrication also. Due to vacuum, the pipe will get upper dimension. Outside dimension is a very close to this inside diameter of this a vacuum trap. This is a vacuum trap method, friend. See now here, the method fixes the outside pipe diameter as it hardens by the contact with the water-cooled metal sleeve. This is a water-cooled metal sleeve here, friend. Here, the pipe is going like this. If you see now here, floating plug systems used for rigid pipe of a medium and a large size. To prevent loss of air pressure, floating plug system is used. What is a floating plug, friend? Can anybody know this floating plug? Floating plug. See here, friend, the plug is here. When the pipe is getting extruded, initially while threading the pipe, that means at the starting, you have to hang a plug at the nose of a die. Right. After that, what will happen? I will show you by arrow also. 1 minute. See now here, the plug is here. And when, see now, here, see now here, and here is we're hanging this plug. See, this is a completely wire is there. And over this, the pipe is going on. The pipe is get slide on this plug, so that the whatever the air we are passing from this side, it should not get escape. Otherwise, pipe will collapse here. And hence, we are giving here a plug, right? A plug here. This is here also, if the pipe is coming like this, we can keep the plug. See now here, this is a vacuum trap. This is also a vacuum trap here. But see now here, we are arranging the plug here in the cooling tank. This is a cooling tank outside the vacuum trap. And in that a cooling trap, we are adding here a plug. Due to that, whatever air we are passing through this pipe, it should not get out. It should not get escape from the pipe. And therefore, we are adding here plug. Due to plug, the pipe dimension, the pipe not collapse at the exit also. And there are many benefits of the plug which is attached to the face of the die by hook. Now, the third method is extended mandrel method. Extended mandrel method, here is, if you want very good shining at the inside of the pipe, then you can use extended mandrel method for sizing purpose. See now here, the material fed like this. See, the water is going inside, water is coming outside here. See, yesterday I have shown you with the screw, how the screw is cooling. Same thing applied here. See, this is a mandrel here, extended mandrel, and the pipe is going over this, and it is get cool here. The pipe will get slide over the mandrel. This is a mandrel here, friends. This is a mandrel. And this method, we just say water cooled extended mandrel. It provides additional internal cooling and internal support. Now, the sizing plate method. Sizing plate method, it is used for a collapsible pipe or maybe a bigger pipe, big diameter. We cannot use this method because small tubing or small pipes we can manufacture by this sizing plate. There are number of plates arranged at a specific distance. As the pipe goes on shrinking, while going forward, that time you will get the final diameter of the pipe at the last plate. And this brass plate, they are manufactured, they are from the brass only, friend. Specific size are there because they are placed in the cooling trap at a specific distance, and hence we are getting a very good size of the pipe. If you see here, friend, this method is quite popular in the market. The pipe takes its size when it is drawn through a series of brass, stainless steel plates. Now, if you see the thickness of these plates are 3 to 6 mm. And here, if you see the size of the first plate and the size of the last plate, the diameter is higher in case of the first plate and the diameter is lower or lowest in the last plate where the pipe get exists. So friends, this is a very unique method to manufacture pipe and which is a get internal finishing. See now here, the combination of all four sizing techniques are there. Just 1 minute, just 1 minute, friend. Here, friend, there are 4 methods I told you to give the final shape to the pipe. See, the first one is a vacuum trap method. Here is a very small sleeve is there, brass sleeve. It's the perforated one. At this gap, I told you 2 to 8 inch gap is there. 2 to 8 inch. See, it's a die, extruder, the pipe, this is a pipe here. This is a ring which will hold the pipe in the water. This is the water here. See the tank, vacuum trap tank, it is not filled completely. It is a 20%, empty is here. Why it is here? Because we have to apply here vacuum. If we apply the vacuum here, what will happen? There is a vacuum pressure, vacuum pressure here. And therefore, the pipe will not collapse inside here. See the water in here, water out. And see that here's a vacuum on this water. See here, this is a water here. This is 20% empty. Tank is not completely full here. It is a caterpillar. Now, if you see the second figure, that is called as a sizing sleeve method. Again, extruder die. See, this gap is again, I told you 2 to 8 inch in between the die and the sizing unit. See the water in here, water out here. And it's a vacuum. Completely vacuum is there. What is the difference between these two? This is a completely a cylinder here, which is a perforated sizing sleeve, a highly mirror finish inside. And therefore, you are getting a outside surface of the pipe. It is a very good as compared to this. You will get a good finish here. And good control also of the pipe diameter, pipe dimension. And after that, you can do the further cooling here. That is we have seen atmospheric pressure. We can again add here subcooling pipes. Now the third method is the extended mandrel method, friend. This is a mandrel here inside. See, it is completely made from the brass. And I told you, water is get in here. We have seen the diagram also. Here, you are adding the water inlet and outlet here. Water going here by pipe and coming here through this outer section. And therefore, this is a mandrel is cool one from inside. And the pipe is going over this mandrel, extended mandrel. And at the top of this, when the pipe coming outside, the water will get sprayed over on the mandrel outside. So the pipe get cool inside by the mandrel and outside by this water spray. And it will get immediately cool at the sizing unit only. Afterwards, if you see here, this tank is exposed to the outside atmospheric pressure here. And again, it has a cooling trap, which will give the further cooling to the pipe. Again, it's a get to the puller. The fourth method is a sizing sleeve method, or maybe sizing plate method, not sleeve, plate methods. There are a number of plates, 1, 2, 3, 4. So the diameter is highest here. Diameter is somewhat less, maybe 10% less. Here 20% less, and maybe here 30 to 40% less. And here maybe 50% less as compared to this diameter. Therefore, diameter goes on decreasing these plates. You see here, in between the die and the cooling tank, there is a gap where the water gets sprayed from the outside. Because there may be a small size of pipe. And it is a less expensive method, friend. And very efficient cooling because of immediately you are spraying the water here after coming out the die. And see now this cooling tank is exposed to the atmospheric pressure. Very good method, less expensive. Many people are using also this. So collapsible pipe you can manufacture by this method. Collapsible pipe, which we can fold and we can store in a specific place. If we have a need, again remove that, again open that pipe, spread, and again pass the water. Therefore, collapsible pipe you can manufacture by this sizing plate method. The last one, this one. Any question here, friend? Any question? Hello? Any question here, friend? Am I audible to you? Hello? Am I audible to you? Friend? Am I audible to you? Hello? Hello, friend. Am I audible to you? Hello? Am I audible to you? Hello? Hello? Am I audible to you, friend? Hello? Hello. Am I audible to you?
Yes, sir.
Yeah. See, these are the sizing techniques are there. 1, 3, 1, 2, 3, 4. Vacuum trap, then sizing sleeve, then extended mandrel, and this is a sizing plate method. Right. I told a very big pipe, you can use this big diameter. If you want outside shining, you use this method. If you want inside shining, then you can use this method. And if you have a collapsible pipe, folded pipe, you can use this, the last one, sizing plate method. There are number of advantages of this sizing methods. We can see now the some video you can I will show you because it's very important to see this video also while learning. Any question here? Hello, hello.
No, sir.
Okay.
What is this liquid, sir?
Yes. See now it is a how the PVC. This is a PVC now. The dry blender, dry blending. See now this is a plasticizer. This is a plasticizer now. Is adding. First he add the PVC powder. Then 30% this plasticizer liquid. Okay. Hello.
Yes, sir. Yes, sir.
This is a high speed mixer. This is a high speed mixer. First he add one bag of a PVC 25 kg. Then he's adding now a 30% plasticizer liquid in that. See, these are the stabilizers, color, heat stabilizer, UV stabilizer. Now he's adding now one by one. See now, it's a high speed mixer now, friend. High speed mixer.
So, sir, this high-speed mixer is having some hole at the top.
Ha.
So that will be open or how?
No. This see, this is a port here, port. Right. It is not open actually. It is a port here. You can see the material, the condition of the material. Right. And that port is this opening here, very small opening at there's the lead here. See now is the lead here. Right. You can close this lead. Okay. While the blending is going on. But there is a small ports are there. That port are helping to add the maybe color, maybe additives, right? Okay.
Okay, sir.
See now is the mixing now. It is a dry blend now, friend. It's completely mixing now that stabilizer. See the plasticizer get absorbed by the PVC. See now he's going to put in the hopper. The color is, he mixed the color also. This is called as the dry blend. See now there's a gap. This is a die. See here. the pipe, see the cooling. A flexible pipe, it's a hose pipe, garden pipe, you can manufacture by this. Very simple method, friend. See now here, the cooling also is doing again cooling. See, the chilled water is here, friend. So the winding unit. With the caterpillar here, so pull the pipe.
Sir, in this, how they maintain the OD?
Hello, hello.
Yes, sir. How they are maintain the OD? There is no sizer here, no?
No. Outer die. It is a very small tubing are there. Therefore, and it is this material is a PVC material, flexible PVC. Therefore,
Okay.
there is a very low tolerance. You will get the accurate here diameter. If you measure the diameter anywhere, you will get the same diameter because it's a PVC material. No shrinkage. Yeah. So it's a flexible pipe, tubing pipe frame. See how now they are. See now they stop the now earring. See now they put the plug there. Therefore, the ear is maintained there. Ear is maintained. Have you seen? See now. This is a here. See is now putting the uh, the outside. See now this is a exposed to the atmospheric pressure. Therefore, she is putting here a complete closing. Therefore, here is maintained here inside. Hello. Hello.
Yeah, understand, sir.
Yes,
Here is maintained inside here. See what she is doing now here. She is just closing one end of that pipe. See now here. She closed now.
So how long it will maintain, sir? Is
No,
there
no,
any
it is-
settling time?
See now it is now ready now. See now she has put their clip. Now the air will not pass, and now the air is maintained in the pipe. See now I will again here. Let her tie this first. I will show you. See now. See now till she will get. See now till she will get the nest. The completely nest cutting. That up to that point it is a get tie one, right? The seal is there with that. Now it is a packaging going on.
So there is any standard for flexible hoses?
Yeah. I will show you. Wait. See now it is a cooling, right? There is a ear inside. The pipe having a ear inside. There is a compressed ear inside. And now see now this plug. See this is here. Yape. See the plug is black plug is there. Therefore, ear is maintained here inside. Ear is maintained inside.
So they are maintaining OD by yeah.
When the complete size will be there, that plug he will remove and he will cut that pipe, and he will again put that plug uh, in the nest, for nest cycle. That girl now you have seen here what she has done. See now here is maintained now. इसमें पाइप के अंदर हवा है. See now here is the inside, and because there is a plug. There is a plug. Here is a plug. See, this black is a plug here. Due to that plug, it is not exposed to the atmospheric pressure. There is a air inside the pipe. We are passing air here only in the die. Okay. Completely air is here inside. And due to air, we get the pipe, the dimension is maintained. The diameter is maintained there. Because the plug is there. Therefore, at one end, you can closing the tubing. See now, also the air is here. And now this plug, the plug will very important. When you remove the plug, the air will be pass out completely. And now this plug, they will put here now. When she cut here, it will for the maintain of the air. See now what she is doing. She's folding. See now she's folding and she's not allowing to pass the ear. See, he's checking now. The ear is there. After tying. Now see now here. She maintain the ear here now. She lock the ear. See how she's putting. Any question here, friend? Any question? Hello? Any question
No,
here?
sir.
No, you can see this video also. See now how he's starting the plant. See how he's starting the plant. See the now here here is a collapse. See now he's blocking the ear now. See, he's blocking the ear. No ear will be passed. This is a sizing. This is a cooling trap. It's a cooling trap. This sizing unit here. See the water is flowing. You see here, going outside. Oh, see, is a blocking completely hot air inside. Threading. He's doing now threading. See how to start the plant. See one by one, they are now doing the threading of that pipe. This is a marker unit. See the sizing unit. Yeah, backside is blocking the water. See now, he now maintain the diameter of the pipe now. vacuum sizing unit. See, this is a vacuum sizing unit here. Now it will lock. See now. Now you will get a vacuum here on this. See the cutter. Cutter come from the bottom. The wheel is at the bottom, friend. Here is a printing. This is a printing unit. Is a counter and printing unit. We should print on the pipe. Any question here, friend? Any question here?
No, sir.
No, sir, no.
Actually, sir, all these videos you are showing are of old models. Nowadays,
Ah,
we are using the extruder like means advanced models, ZSK and all.
no. This is a no. This is actually how the threading is doing. What happened? Generally, the automatic plant, you cannot see the how they are working there at the starting level, right? Therefore,
Yeah.
this type of video will show you how they start the plant, right? If you see the
Okay.
new video or new machines, you will not get such a type of things there, friend. Direct they are showing the videos. Therefore, you will not understand the sizing unit. Where is sizing unit? Where is the cooling unit? Where is the die? Where is the that the other inline equipments are there? You cannot understand there. But see now here how the skill they have acquired, and the manually they are getting the good the size of the pipe, a good maintain quality. Now, friend, corrugated pipes. We are just shifting the other now corrugated pipes. Have you seen the corrugated pipe?
Yes,
corrugated
sir.
pipe. हाँ, corrugated pipe कैसा होता है पता है आपको? How it?
वॉश बेसिन के नीचे लगा रहता है वो
Yes. It is just spring
राउंड टाइप
like.
में
Double
स्प्रिंग टाइप.
double wall, single wall, right? That pipe is nothing but it is a corrugated pipe, and that pipe, it is it is like a spring, right? You can increase the size, you can decrease the size of that pipe, length of the pipe. Now, which are the common material for that? See, the corrugated pipe have either parallel ring growth or continuous helical growth. The pipe design can be single wall or double wall. Most common thermoplastic are PVC, polyethylene, polypropylene, polyamide, and fluoropolymers. The most common important advantages are considerable raw material saving, because these are the very light one. High pressure resistance with a good flexibility, high impact. Okay, then good hydraulic characteristics. These are the main. See, this is the pipe, corrugated pipes. How it is manufactured, right? We want to know that. If you see here, 4 to 8 inch double wall. See, double wall pipe A. Okay. See now, this is also corrugated pipe. 4 inch double wall corrugated drainage pipe. See, we are using this for our basin. The process, it is similar to extrusion pipes, except the die. Here only the die is different, friend. All other things are completely same here. Nothing, no change at all. Therefore, how the die work here? That is very important, friend. Here, how this die work? Here is a die opening in a both sides. There are some blocks are there. If you see the when the pipe passes through the forming machine, it is get cool by that blocks. The block is already chilled one, right? The water gets circulated inside the blocks. Therefore, these more block chains are there, and that plastic tube is pressed against the profile revealing the mode blocks, and internal air pressure is maintained there by vacuum process. If you see this thing, one video, you can understand how it is working. I will show you the video also of this. See, it's a double wall. It is a, see here, the black color and the yellow color. See here, it's a die. Only the thing is die here, friend. See how the die rotating. See the blocks are there, chain blocks. This is the, the parameters. This is the, all the visual things are they are showing here, working plant. See, these are the blocks here. It is getting hit. It's a cool. It's a cooling lines are there. See, these are the cooling lines to cool the. See the shining. See the pipe. How the pipe is get coming forward, and they'll get completely chilled one. Completely chilled one, friend.
Sir, here they are using air cooling or water cooling?
Here, no, water cool, chilled water cooling, chilled water cooling.
Okay. Oh, yeah, understood.
Yes, yes. See now here, water drop is outside. See now here. After forming the pipe, see the water has get, from the outside also, spraying the water also. See how it is maintained now here. See the now cutting take place now. The pipe is get cut now. See now here. This is a cutter which hold the pipe and then cut. There is circular cutting. Now, friend, see here. We have seen this a pipe, right? These are the blocks are there like that, and we are manufacturing corrugated pipe. This is now screw. See now here. The die is same like our die, but see now here the die. This die is changing here. There's a block chains are there, and they're opening here and they're closing here, and in between, due to that, the hot material get when the coming out. That time, due to the design provided at the chain drive, they get impressed on that the groove-like structure, and you will get a completely a groove structure around that pipe. The pressure or vacuum sizing becomes effective here, friend. The molten tube must be brought over a special extended outer die ring as close as possible to the molding chain. Otherwise, tube would be blown off, pressure sizing and fail in the vacuum sizing, correct? The extended portion of the outer die ring cannot be heated separately, so that it must be made of the material of a high thermal conductivity. The friend, double wall corrugated pipes production, I told you, the first formed. Then after that, second tube is laid smoothly on the inner surface of the pipe. Then it corrugated and then welded to the first with the aid of the sizing mandrel. This is the process of this frame. We will stop here, and tomorrow we will meet at 6:30 again. We will start the other plant, that maybe sheet or maybe blown film plant frame tomorrow. Correct? If you have any question about
Okay,
the
sir.
pipe, if you have any question about the pipe, you can ask me today also or tomorrow also, no problem. But we will
I
again
have a
discuss.
question regarding extrusion. Is there any relations between melt pressure, temperature, and load? You have any sheet to understand about?
No, there is a difference upon the material to material, because I told you regarding the PVC, the pressure is same there. It is just by practice only, friend. You have to maintain the pressure, air pressure inside. There is a air pressure gauge is there. By that you can measure the pressure there, and you can maintain the same pressure for your all process. Okay. Any question? Again?
Yes, sir. I am asking about melt pressure, sir. Melt pressure and melt temperature.
Melt temperature. Melt temperature
Melt
is
temperature, melt pressure.
melt temperature. See, the melt temperature is same as per the that our processing, right? There's a above the melting point only. There's no any difference there. But you have to maintain the viscosity. It is the trial and error method, friend. You have to put the a flow viscosity of the material. Okay. And there's a nothing a big change there, friend.
Okay, sir.
Yeah. It is just
And
you have
then
to keep
about screw output calculation, like rotation.
screw.
Yeah.
The screw is designed as per the material. That is very important here. If you have a different material, you have to use that I have told you. For nylon different, for PVC different, for SDP different. You cannot use the one screw for the other material.
Yes, sir. In screw, somewhat they have a different type of screws, like conical screw, parallel screw. They are calling twin screw method.
Yes, twin screw. They are the self wiping screw. Self wiping screw generally used, because these are always good. That material should not get degraded inside the barrel. Therefore, self wiping parallel screw are used here. Even Cincinnati screws are also used here. Cincinnati conical type of screws.
Okay,
And
sir. Is there any slide to explain about this by tomorrow?
We can see if it is available, then I will bring that. But it is okay. Just we will check up the. Okay.
Also, you have any HDP pipes production plant like these videos?
Videos I am sending there with IPR department. You can collect from this all, because I am just sending this all my the records. They are get recorded, and you will get that link also there. They will going to send you details. Don't worry.
Yeah, still we didn't see the HDP pipe production, so that's why.
SDP, na?
Yeah,
Yes,
HDP.
tomorrow. Yes, tomorrow I will show you the video of that. Okay.
Okay, thank you.
Yeah. We will meet tomorrow, friend.
Thank you. Good night, sir.
Bye.
Thank you, sir. Good night.
Good night.